Hello, everyone. I hope you are not feeling gloomy like the weather. It's foggy. Can you believe the buildings from here? I can see them anymore. It's so foggy. Anyway, how are you guys doing? Good. So the plan for today is to going over page 1 and 3 of your exam, and then what will be in the exam from the review sheet. Okay. And you may wonder why I'm going over the exam when the exam is tomorrow. Because whatever we have here, you're going to see them again tomorrow. Not the same thing, but same rules with different examples. Okay. Any question before you start? Comments, concern, complaint? So the first entire row is the rules for power 0. So the rule I told you before is that if you have anything, positive, negative, fraction, anything, as long as it's not 0, and if you raise it to the power 0, what's the answer? 1. So that tells us the answer for the first one. Oh, and what happens when you have 0 to the 0? Doesn't exist. So 0 power has only 2 choices. As long as base is not 0, the answer is 1. If the base is 0, the answer doesn't exist. So what is 2 to the 0? What is 0 to the 0? Doesn't exist. What is negative 7x to the 0? 1. What is 1 to the 0? 1. So as long as your base is not 0, the answer is always 1. However, there's a different scenario. What if I give you negative 7 and then x to the 0? Then what will be the answer? Negative 7. Because see, this 0 only belongs to the x. It gives you 1. So it's negative 7 times 1. The answer is negative 7. The difference between that's the green one and what we have here is that here we have a parenthesis, means whatever we have inside the parenthesis, it's base, it's on the base. But the negative 7 on the top, it's negative 7 times x to the 0. So be very careful. What is your base and what is not on your base? Okay, so we have 0 rows. We are happy. The next row is 0 base. So for 0 base, let me change the color. 0 to 0. We know 0 to 0 doesn't exist, right? No problem. And what is 0 to the any positive whole number? So let me start with negative. Let me start with negative. Okay, 0 is any negative number. Any negative number. It's DNA because negative form is a fraction. So we have something over 0. We don't know how to divide by 0. So it doesn't exist. So when you have 0 to the 0, we don't know what that is. When you have 0 to the negative, we don't know what that is. So 0 cannot take negative power or 0 power. It can only take positive power. Positive whole number, positive fraction, positive anything. As long as it's a positive number, what the answer is? 0. See, 0 has only 2 rules. Either DNA or 0. It's DNA if you have 0 or negative. If 0, you have positive number. And if you forget your rules, no problem. Work with an example. For example, What do you have for 0 square? It means 0 times 0. What is 0 times 0? 0. And negative power, let's say you have 0 to the negative 2. It means 1 over 0 square. What is 1 over 0? Doesn't exist because we don't have to divide by 0. And 0 to the 0, just remember it doesn't exist. So if you forget, no problem. Work with some examples to figure that out. But try not to make any more mistake because these are easy points. So what is 0 to the negative 1? 1? Negative power, come on. Doesn't exist. What is 0 to the 11 power? 0. What is 0 to the 1/2 power? Still 0. As long as the number is positive, it doesn't matter what number you have. You can have whole number, you can have fraction number, it doesn't matter. The thing is sign. If the power has a positive sign, it's 0. Then comes the rules for 1. And 1 is the most amazing number. 1 with anything. It could be positive, it could be negative, it could be 0. 1 with anything. 1 is the most generous number. It doesn't matter what we throw to it, it always stays same. That means what is 1 to the negative 1/2 power? 1. What is 1 to the 6th power? Still 1. What is 1 to the 0 power? Still 1. And then when you flip, what do you get? The negative becomes positive, it becomes 1 over 1. What is 1 over 1? So that's why you can have any number on your power, as long as your base is 1, that's all you have. That says always 1. Now comes, what color I can pick? Negative 1. Now, negative 1 has 3 scenarios. I gave you 2 in class and I forgot to give you 1, which I didn't notice before. So first start with negative 1 with odd number. Negative 1. So that odd number could be anything, could be whole number, could be fraction, it doesn't matter. As long as your power is odd, the answer is always negative 1. Always. Okay. And now comes the even. Even has 2 choices. Either you have negative 1 to the even whole number, or you have negative 1 to the even fraction. With the whole number, what's the answer? 1. Because let's say negative 1 square, it means negative 1 times negative 1, it becomes positive 1. And it's true for any even whole number. It doesn't matter how many times you have, if you have, as long as you have negative even many times, the answer is always 1. Always. Okay? Now, what happens when you have negative 1 inside the even fraction? For example, let's say you have negative 1 to the 1/2 power. 1/2 is an even fraction, right? Because our denominator is even. Now, 1/2 means which root? Which root? Fraction power means radical, right? So which radical we have here? Square root. What is square root of negative 1? Doesn't exist because it's imaginary. Let's say here 1 to the negative 1 to the 1/4 power. 1/4 means you have 4th radical. Jenny. The negative 1 actually cannot have any even fraction. So anytime you have even fraction, the answer is 10. Which I didn't notice before until yesterday. So I'll give you all of these examples again. Now, based on these rules, what is -2 whole thing to the power 0? 1. What is -1 to the power 7? -1. What is -1 to the power 10? 1. And let's say I'm giving you one more. What is -1 to the power 1 over 10? It's DNA, because 1 over 10 is even, still even. It's a fraction, but it's an even fraction. So it doesn't exist. And one more here. What if I give you -1 to the 1/7 power? What is 1/7? Odd or even? Odd. So what's the answer? -1. So see, it could be positive whole number or could be fraction number. It doesn't matter. The answer is always -1. And it's because -1 to the 1/7 means find one number, multiply 7 times, the answer is -1. This is what 1/7 power means. Find one number, multiply 7 times the same number, and the answer will be -1. So it's -1. You can multiply -1 7 times, and the answer will be still -7. So -1. So I'm going to give you more example on each scenario. For example, few example here. Okay. Because these are fun. Any questions so far? Then comes the regular exponent rules. When you multiply the bases, what do you do with the powers? Add them or multiply them? Add them. So we get x to the 7. When you have two powers together, do you add them or do you multiply them? Multiply them. So we get x to the 10. And when you divide, there are two choices, right? Either the numerator bigger or denominator bigger. When you have denominator bigger, what is your answer? Whole number or fraction? Denominator is big. So we have x squared divided by x to the 5. What's the answer? 1 over x to the 5 minus 2, which is 3. So 1 over x cubed. How about the other way around? X to the 5 divided by x squared. It becomes the whole x cubed, not the fraction x cubed. In division, what do you do with the powers? Distribute. So we have x to the 5 over y to the 5, and it doesn't matter whether you have multiplication. It is the same thing, distribute. So x to the 5 times y to the 5. Whether you have a multiplication or division on your base, if you have one power, everyone wants to get that power. And if you have a negative power when the base is fraction, what happens? Flip, so y over x, and then it distributes 5, 5. And now comes the negative rules. A to the -1. 1 over a. Always fraction. What, a to the -2. 1 over a to the +2. A to the -m. 1 over a to the +m. And when you write in 1, it has to be a big line, okay? So 1 over this and 1 over this, they are not same. This means you have fraction 1/5, 1 over m power, and this means you have a fraction 1 over a to the positive m. So be very careful. How do you write this? This means you have mth radical of a. But this means you have a to the negative m. They are completely different things. So when you give me the answer, if you mix them up, you're going to get 0 because I see it before in some of your paper. When you give me the answer for this, you wrote that, which is wrong. And when you give me the answer for this, you give me that, which is wrong. So anytime you have a radical, it's fraction on little bit to your right side of the number, right side of your base. And when you have a negative power, the entire thing becomes fraction, not the power only. So this is 1 over our a to the m. This is 1 over a to the 4/5. So we have to write 1 over a big line and then the denominator. This is 1 over 2q. And since 2q is a small number, I expected it to give me 8 because on the choices here 1, 8, but it did not have a choice 1 over 2q. And I said on the top, pick the answer from the choices so that you don't make the mistake here. Now y to the square root, so the square root to the square root of y, it means y to the 1/2. You write it y, and 1/2 is on the top of the y, little bit to your right, as a superscript. This one is y to the 1 over n. It's not 1 over y to the n. They are not same, okay? I'm warning you guys. Don't make the same mistake. The last one, the power has the more priority. So power goes in the numerator and the radical goes in the denominator. It's on the side, okay? Not on the top. So all of these are rules, and the next box is the application. Which y? Square root of y? So let me get it here. First one is square root of y. Second one is mth root of y. M. And the last one is m power and nth root. Anytime you don't see a number, that means you have an invisible 2 there. So it's y to the 1/2. And now we do see a number. So it's y to the 1 over m. And this is also y to the 1 over m. But now our y doesn't have anything. So it's not like our y doesn't have anything. It does have something. It has a m as a power. So this 1 turns into m. When you don't have a power, you have invisible 1 there. So every numerator is 1. But when you do have a power, visible power, that means that goes in the numerator instead of 1. Oops. Then comes how much you understood from all these rules. -3 square. What is our base? Only 3 or -3? -3. So it's -3 times -3. What's the answer? 9. On the next one, what is our base? -3 or only 3? The next one, only 3. So it's negative times 3 times 3. So it's negative. The next one is a negative power. So it becomes a fraction, 3 square. And what is 3 square? So it's 1 over 9. And then the next one has double negative. The first negative is a multiplication. The second negative is a fraction. So it's negative 1 over 9. So observe carefully what each negative means, how it's connected. Is it connected as a multiplication, or connected as a base, or connected as a power? Because depending on their position, we get different answers. Now 1/2, it means square root of 4, 2. The same thing, but this is a negative 1/2. So it's fraction square root of 4. So it's 1/2. And the next one, we have a negative and then 4 with 1/2 power. So it's a multiplication and then square root of 4. Negative 2. And the last one says we have a base negative 4. So negative 4 inside the square root. What's the answer? It's imaginary, so in real world, it doesn't exist. And see the rule? If you have a negative base with the even power, even fraction, the answer doesn't exist. This rule. Negative base, but your power is an even fraction, the answer doesn't exist. Any question, Robert? If you have a parenthesis. Now I'm going to give you this again. There's a finalism question, and almost 95% got 95 or 98, I don't remember, of you got this wrong, which is disappointing. This one. G. G, the bigger one. So what do you do first? Surprisingly, most of you got this correct, but half of you got it correctly correct. What does that mean? You could tell me easily that we get square negative 3, x negative 3 square. This part was remarkable. Almost everyone got it correct, almost everyone. And then you told me that 2 to the negative 3 is negative 8. Is 2 to the negative 3 is negative 8? Is it? How would you even think that? Negative power, how can it give you a negative number? Negative power means a fraction, not a negative number. So if you knew your rule correctly, why are you telling me this negative 8? And that's where I made the mistake. The answer was half price 8, but not negative as a fraction 8. That's what I said. Don't do anything with the negative power until you write negative into positive power. Because when you convert them into positive, you see clearly what is happening. But when you have a negative power, you don't see what is happening. So keep your negative power. And some of you told me that this 6 square is actually 12. How can you multiply 6 and 2 if you are multiplying the power with the power? You know how to put, you know that you just distribute the power here, 6 and 2 multiply. But why are you multiplying 6 and 2 and give you the 12? How 6 times 6 is 12? Exactly. The answer should be 36, not 12. So I don't understand you guys. Like you multiply the numbers, even though you know how to multiply, even though you have to distribute the power to the variable. So distribute the power to the variable, but you multiply the power with the number. Remarkable. So don't do anything until you make your negative into positive. So bring this negative on the denominator. So you already have your 36. And now you have 2 to the 3, x to the negative 6, x to the negative 6. Now, yes, you can convert them into positive, but here you don't have to, because look, you have the exact same same things on the numerator and denominator. So you can simply cancel them. You don't have to convert them into positive because they're same thing. If one of them was 5, one of them was 6, then we couldn't do that. We have to move them around to make them positive. But when you have same thing, just cancel them, no problem. So we have 36 times 8 on the denominator. But we canceled everything from the numerator. So what is on the numerator? 1. Most of you forgot to do that. 288 is not on the numerator, it is on the denominator. That's why the answer is wrong. So what was the most sad thing was, some of you are amazing, you did everything correctly, and then here you thought this is the whole number 288. That is 288, right? So whole number 288, but still it's not the whole number 288, fraction 288. That was points. See? That was the most sad one. Like you knew what to do, but then at the end, you forgot your small one on the top. It's 88 because 6 times 8 is 48. So you have 8 at the end. Send this. You added. Yeah, I noticed that. You always added everything. Why do we add? In exponent rules, we never add. You always multiply numbers with the numbers. Always. All those exponent rules are based on multiplication, not addition and subtraction. When you have addition and subtraction, we actually have no rules. We don't know what to do with the exponents with addition and subtraction. So all of these are multiplication. So I'm going to give you very similar question again tomorrow. Maria, which part is confusing? Step 1, distribute the power. Yeah, that's that. 2, negative 2 power. This thing, negative 2 power. Denominator is 2, so 6 with the 2 power, x to the negative 2 with the 2 power. Clear?
So you just take out the 2 on the side. You just put in the 2 to the 6. The 3 to the 2.
The numerator is the negative 3 power, so it goes to 2 and x squared. Denominator is positive 2 power, so it goes to the 6, it goes to the x to the negative 2 power. And then you use the exponent rules, the 35 points. Negative with the negative power with the number, don't do anything until you make it positive. 2 powers together, you multiply, so you get negative 6. 2 powers together, you multiply, you get negative 6. And in a 6 is a positive power, so we can expand. So 6 squared gives us 36. So if it's a positive power for the number, you can expand. If it's negative, don't do that. Don't give me negative because the answer is wrong. And then here I have the exact same thing on the numerator and denominator, so you can cancel. But if you have different thing, then you bring them up and down to make them positive, and then apply your division rule. So all you have to do 3 steps. Distribute, reposition based on negative power, and then rewrite. Any question? So from the exponent rules, these are the questions you're going to see again. And now we have our favorite factoring. You're going to see them again. Not the same thing, okay? Event. Question? We started with first, or I'm going over the exam, the first page and the third page of the exam. Medicine. Exam, not the review sheet, exam. The exam from yesterday. The first page and the third page of the exam. Remember I told you bring your exam today because I'm going to go over them. Medicine. All types of factoring. So here we have 3 types, 2 terms, 3 terms, 4 terms, but we learned more about 3 terms later. So all the things we learned, everything will be there. Now let's go over this because these are fun ones. A square plus B square. Do we have any rules for plus? This is sum of squares. We have no idea. So it's prime. Anytime you have a sum of squares, we are stuck. We don't know what to do. But when you have difference of squares, then we can factor. So difference means you have a minus, okay? That's why it's called difference. If you have difference of perfect squares, it's factorable. If you have sum of perfect squares, it's not factorable. So the two factors from the difference we get is we observe their bases. It's too dark. I'll make something green. I love green. So you take your two perfect bases and then you add them, right? A plus B and then A minus B. So difference of squares has an answer, but the sum of squares don't have any answer. It's fine. So two terms, they have two choices. Not choices. Two options. Either we are working with difference of squares or we are working with GCF. So here, even the 16 is a perfect square, but we don't have 16 alone, we have 16x. Catherine? Multiplication doesn't matter. So if you had x squared minus 16, it would have been perfect square, but it's x squared minus 16x. That means it's a GCF. So this is GCF. What am I writing? Come on. This is DCF and this is difference of perfect squares. When you have two terms, you have two choices. Actually, you have three choices, my bad. One is prime, which is not factorable. One is you have to pull out a GCF, or you're going to use difference of perfect square formula, not formula method. So first one is prime, the second one is GCF. You factor out it x, and what remains? X minus 16. And then you have to stop because x doesn't have any square. It's simple x, so you don't have to factor more. So prime, GCF, or difference of perfect squares. How about D? Which one of these? GCF. So what do you see in common? When you factor that out, you're left with x plus 3. How about E? Difference. It's not same, it's perfect squares. So 25 is 5 square. X plus 5, x minus 5. In multiplication, 2 times 3 is same as 3 times 2. So it doesn't matter. Because you don't have any GCF. This is 25, doesn't have any x. What can you pull out as a GCF? Now F. What do you see in F? First, you have to pull out a GCF. What can you pull out? What remains? And now many people stopped, so lost 2 points. What is x squared minus 49? Difference of perfect squares. So that means you have to go more. X plus 7, x minus 7. So either it's single rule or it's both of them together. GCF and perfect squares. Just because you apply one rule, it doesn't mean you're stopped. I mean, you're done. You have to stop. You have to see, can you factor more? If you can, you have to go further. And then you have 3 terms. So all of these 3 are direct factoring. You look for 2 numbers, multiply to 30, combine to -1. 5 and 6. Decide their sign. 6 has to be negative by the rule. That means 5 has to have positive sign. The next one, very similar. Two numbers multiply to 30 but combine to 11. They have the same answer. The only difference is, so here 5 is plus, but here 5 is minus. So when you have bigger number, that means you have to add the two factors, so they have to have the same sign. When you have smaller number, that means you have to subtract the numbers, that means you have to have two different signs for each factor. So smaller number means you're subtracting, bigger number means you're adding, so they have to have same sign. And you can always figure out the sign for the bigger one, the middle term. So direct factoring, that was easy. And then we have the next one. First you have to factor out a GCF. What do you see in all three? X cube, not X only, okay? It has X5, 4, X3. You always take the smaller power. You must take out X3, X to the 3, which is X cube. What remains? Minus 28. And then you thought it's prime because you did not know your timetable well. It's not prime. We do have two numbers multiply to 28 combined to 3. Minus 7 plus 4. 7 times 4 is 28. 7 minus 4 is 3. So it is factorable. Jolene, come here. And then more direct factoring. Two numbers multiply to 6 combined to 1. Sorry, combined to 5 this time, not 1. Negative 3, negative 2. If you think it's 6 and 1, it doesn't work. Because if you 6 and 1, 6 has to be negative, 1 has to be positive. Even though the sum works, but look at the multiplication. Negative 6. But you have positive 6. So if you give me the answer with 6 and 1, you get 0 points. So 2 terms, 3 choices. 3 terms, 1 now. We have direct factoring. And now we have 4 terms. So first we're going to pull out GCF and then grouping. So we have X in common. We pull out the X. You left with what? 5x squared plus 6 minus 10x cubed minus 12x. We group them into 2 groups. First group, second group. What do you see common in the first group? Nothing, right? When you have nothing, you can factor out a 1. And you have 5x squared plus 6. But what do you see common in the second group? You see a 2. Anything else? X. And then how your second group started with? Positive or negative? Negative. Would you like to start your day with something negative? No, right? Same thing, polynomial doesn't want to start with negative number. So you have to factor out a negative. Maria, question? No, because you're going to factor by grouping. So look at the first group. They have nothing in common, so we have 1 invisible. And then we have these. Now they do have something in common. 2 and X, and we must bring down the negative because we want to start with negative.
And then the other sign change, right?
So what is left in the negative 10x cube? Only 5? Second.
No, it's the third. 10 to the fourth. I don't know. No, it's six.
And then 12x equal out the negative 2x plus 6. Because you're dividing by a negative.
So when we're finished, we put the 5 plus 6 first, or we put the 1 in.
We still have both the group, right? So what do you see in both groups? 5x squared plus 6.
So you always put
In multiplication, the order doesn't matter. But I like to do it fast because I'm showing you that they both have 5x plus 6 and pulling it out is a common factor. And then I put together what is left. 1 and minus 2x. And you cannot forget about our DCF. So this has 3 factors. If you tell me here your factor is only negative 2x, it's wrong. Because if you multiply them back, you don't get the original one back. That's why I showed that we have to pull out a 1. Even though they have nothing in common, they still have to factor out a 1. Because they need to be combined with the second group. Any question? Okay, so 2 times, 3 times, 4 times, and now 2 times, or, I mean, never mind, not 2, 3. Main concept here is a 4th degree. We have questions with 4th degree. So 4th degree, they may have 2 times or 3 times. It doesn't matter what do you have, you follow similar rule. If you have 3 times, it means direct factoring. And if you have 2 times, means perfect squares. So difference of perfect squares, if you have 2 terms, and it's direct factoring if you have 3 terms. So direct factoring means it factor directly. So let's see the bottom first. 2 numbers multiplied to 24 combined to 2. What are they? 6 and what? So positive 6, negative 4. Many of you were actually able to do that, but then you gave me the wrong variable. What is a variable here? It should be x squared, not x. But in the exam, you gave me x. And you can already see it's wrong because if you multiply x and x, you get x squared. But how many x you have? 4 of them. So definitely cannot put x. You have to put x squared so that when you multiply x squared, the x squared, you get what they give you, x to the 4. Sad news, many of you stop after getting your 2 answers, 2 factors. Can we stop here? Exactly. We have more factorable factor here. So we have to go further. It's difference of perfect square, so it's x plus 2, x minus 2. And this is not factorable, so we just bring this down. If you did not factor the x squared minus 4, you lost the points for the 2 factors. I gave you 1 point for the first one. But why did you put the other 2? I didn't see them. Go ahead, Brianna.
Why did you break down both of them? You factored out the x plus 4 twice. Like you did perfect square for the x plus 4.
X squared minus 4. Send this. Why? Plus, it is a plus sign between them. Anytime you have a plus, it's not factorable. Okay, the next one. Two numbers multiply to 24 combined to 11. 8 and 3. So how about the signs? -8, -3, and our square. And this time we can stop here because none of these are perfect square. 8 is not perfect square, 9 is. 3 is not perfect square, 4 is. So if you don't have perfect square number, don't go any further. Stay. It's not more factorable, but this is more factorable because of the perfect square. And then we have fourth degree 2 terms. Fourth degree 2 terms is always your goal is to rewrite them in this format. We want to have difference of two perfect squares. So how can you rewrite a to the 4 with something square? What square is a to the 4? A square. What square is b to the 4? B square. Now, do you have two factors you can see here? What are the two factors we get from your perfect squares? So these are our bases, right? The base gives us the two factors. A square plus b square, a square minus b square. So this is prime, we cannot do anything, stop for this one. But how about this? It's difference of two perfect squares. So you have to go further. A plus b, a minus b. When you combine all of these, you get a square plus b square prime that you cannot factor. A plus b and a minus b from a square minus b square. And now you have your all three factors. You cannot go any further. Let me tell you what will be in the exam. So we see in two terms, right? Two terms has two choices. One is prime. One is GCF. Difference of perfect squares. So I'm going to give one for each. So 3 questions from here. Then we have 2 terms. Not terms, terms. Now for 3 terms, in here we have direct factoring. Direct factoring. It means you look at the constant and you divide your 2 numbers. And in chapter 6 later, we saw SE method, right? And we also see in trial and guess method. These are factoring. 3 different questions, not together. So one question about direct factoring, one question with the SE method, one question with the trial and error method. So 3 questions from here. Robert. I'm going to give you the choices because the numbers are big. Tomorrow. Then we see 4 terms. 4 terms had GCF plus grouping. So one question. Either only grouping or GCF plus grouping. Actually, let me should write down the numbers here instead of here. Huh? 4 terms. 1, 2, 3, 4. You have 4 terms. And then we have 4 degree. DRGEE. 4 degree. Like something to the 4 minus something to the 4. This format. Or the other factor, the other method, like either this or that. So we see 4th degree has 2 things. Either it's difference of perfect square or it's direct factoring, right? The first one is difference of perfect square. The bottom 2 is direct factoring. So 2 choices. I'm going to get 2 from here. X to the 4. So how many factoring? 2, 3, 4, 5, 6, 7, 8, 9. 9 factoring. Any question? And now in chapter 6, we did two more concepts. One is solve for x. So one of solving for x. To solve for x, you factor first and then you solve. And then we did real life application. So one of these. And that's it for from chapter 6. A ball is throwing somewhere. Those things. So I forgot how many we have total. 9, 56, 7, 8, 9. Total 9 factoring, 1 solving, 1 application. So 9, 10, 11. 11 questions from chapter 6. And then many questions from your exponent rules. And now we are going to the chapter 7. Chapter 7, I'm going to give you only 3 questions. One is find the domain in interval notation. Multiply and divide. So multiply the rational, divide the rational, find the domain. 3 concepts, 3 questions. In our last class, I said I'm going to give you one simplifying, but you don't have to do simplifying because when you multiply and divide, you do the simplify automatically. So I reduce the number. Instead of giving you 4, I'll give you 3 here. Domain, multiply, divide from chapter 7. That's it. Direct factoring method. What? Which one you saying? Oh, direct difference of perfect square. I'm too lazy to write this down. Difference of perfect square. So just abbreviation. Did you know how many questions? 9, 10, 11, 12, 13, 14. 14 math question. 14 math question, and the rest are exponent. Okay. So few of them you have partial credit. Few of them are not going to have partial credit, like either full points or 0 points. Which one you want partial credit?
Partial credit? Chapter 7.
Chapter 7 you want partial credit. And chapter 6 either full or 0.
Or maybe like real life application. Everything partial credit.
Robert wants to take the exam like final exam to prepare yourself for the final exam. The final exam is this policy. Either full credit or no credit. What 80, 85 points or something on full credit or zero credit. And then only 18 or 15 points are on partial credit. So what do you want to have partial credit? 7 or 6? 7? How can you have partial credit on exponents? So exponents are either 1 point or 0 point. No partial credit because it's on 1 point for each. But these are going to have more points. So I'm asking you, what do you prefer? Like, here's for real life in chapter 7. Chapter 7 is only 3 concepts. Or real life and chapter 7. Credit or no credit, which one? I mean, partial credit. Partial credit. What do you prefer? Yeah, 6.7. I'm going to go over chapter 6, these two, and chapter 7 real quick. But I'm just asking you, what do you prefer? Where do you want your partial credit? Chapter 6 or chapter 7? Or you want 7 to your partial credit? Okay, so you already seen chapter 6. Let's do one question about trial and error from chapter 6. Let's say this one. 17 and 28, two big numbers. If you multiply them, you get two big numbers. So trial and error is best. You look at your choices, you split them. So you have 17 and 1. This will be 17 and 1. And for 28, how are you going to break down 28? Look at the choices. We have 4, 7, and 28. So is it 1 times 28 or 4 times 7? 4 and 7. Because I say both of them. So when you say both of them, take that pair. That's what I really want. That's what I really want. Good. That's why I say this is easier if you have the choices. Because you can see your numbers. Leandra. Everyone got factoring wrong. Factoring? Yeah, I was also thinking about factoring because if you miss a factor, at least you get partial credit. But if you miss a factor, you get 0 credit, which is bad. Yeah. If you get some for regular one. Okay, so once you have your two things, then you play around and see which pair gives you 61. This pair is wrong. We're not going to get 61, right? I think. So you do this way, right? 7 times 14. So 17 times 4, 28. We have 68 and 7. Yeah, this is correct. So this pair gives us 68 and this gives us 7. 68 has to have which sign, positive or negative? Negative, because our middle sign is negative. That means 7 has to have what sign, positive or negative? Positive. So since 68 has to be negative, we got 68 from 4 and 7. Sorry, 4 and 17. So by default, these two cannot be negative. They're always positive. So product of 7 and 17 and 4 is negative. That means 17 has to have what sign? Negative. And since product of 7 and 1 is positive, 1 has to have what sign? Positive. Once you figure out your sign, two numbers, your life is easy. You put 4x and 7x. So we multiplied 4 and 17. That means we cannot put 4 and 17 together. So our 1 goes with 4, 17 goes with 7.
Are you gonna put us the numbers next to it?
I'm going to give you the choices.
For one question on this or two?
1. And then solving. When it says solve for x, it means you need to factor and then solve. After factoring, you don't stop. You have to do more. And in order to solve, you have to have everything to one side. Okay? Otherwise, you cannot solve. Robert. To make your life easier. So in order to solve, first you have to bring everything to one side so you can see 0.
So 7 was positive, was negative.
Into positive. But I'm not going to do this one because this is direct factoring easy. I went to do B because we're going to use AC method here. So let me refresh your memory with the AC method. You have your A and C. They multiply 5 and negative 21. And if you multiply, you get this big number, right? 1 of 5. And then you have two choices. Keep dividing them and see what gives you, which two number gives you 32. Or you can simply use 5 and 21 and split them. Like trial and guess. It's up to you. You do trial and guess here, or you do division, divide by 2, divide by 3, divide by 4, 5, 6, and see which pair gives you the middle term. So since you don't have time in the exam, so don't multiply and make it bigger. Instead, start with the trial here. This is definitely 1 and 5, and this is 3 and 7. When you break them down, try to break them down into prime numbers and see which pair gives us 32. If you do 3 and 5 and 1 and 7, do you get 32 from here? We have 15 plus 7. We don't get 32. So instead of this pair, we are going to pair them other way around. 1 with the 3, 5 with the 7. 3 times 1 is 3, 5 times 7 is 35. And yes, this gives us 32. But how about the signs? Which one is positive, which one is negative? What sign is in the middle? So which one is negative? The bigger one has to have the middle sign. So 35 has to be negative. V has to be positive. Remember, the sign always depends on the middle one. Bigger number always gets a middle sign. So you do grouping method. We have 5x squared minus 33x minus 29 equals 0. You keep your 5x squared, keep your minus 21 and 0, but you break down your 32 into negative 35x and plus 3x. You end up getting 4 terms. That means grouping. What do you see in the first group? What remains?
7.
Minus 7. Then we have plus 3 x minus 7. You still see what in both groups? X minus 7. So what remains? 5x and plus 3 equals 0. So if it's a factor, you stop here. Why did I say factor? It's a solve. Solve means you get the x alone. So x minus 7 is 0, or five x plus 3 is 0. And then you solve. You get 7, you subtract 3, and then divided by 5. I'm doing in a rush, but you have to do it step by step. So you get 2 solutions. This is what you do for solving. One of the solving will be that. And the application, I'll give you the same question to make your life easier, but the function will be different. So all you have to do here is set your function equals 0 and solve. Negative 5t squared plus 20t plus 25 is set that equals 0 because you're hitting the ground. When you hit the ground, your height is 0 for the ball. And this function is the height function. To solve, it means you're looking for factoring. So what do you notice? Huh? Yeah, but we have -5, right? So what can you do? Instead of multiplying, what do you notice about all these numbers? 5. Divisible by 5, right? So divide this by -5, this by -5, this by -5, this by -5. Because first of all, you don't like the negative, and 5 is divisible. Every number is divisible by 5. So divide by 5 to make your function smaller. So what do you have in the first term now? In the second term? -40. In the third term? +5. Now does it look more fancier, nicer? Can you factor? Yeah, -5, not positive, sorry. Two numbers multiplied to 5 combined to 4. 5 and 1. Sign? Variable? T. And then what do you do? Send this question? No, because see, all of these are divisible by coefficient. So anytime you can factor out anything, first factor that out, or if you're solving, divide that out. No, -5 because the middle sign is minus. No, but we have to take something. And make 2 more with that, or no? T -5 equals 0. So we get t equals 5. And we have t plus 1 equals 0. So we subtract 1, that gives us t is -1. Do we have any problem with any of the solution? -1. Because t is time. We cannot have negative time. Then the only answer is 5. So from 7, we have domain and multiplication division. So for domain, all you have to do is take a denominator and set it equals to not 0. Yeah. Okay, never mind. So it doesn't matter what domain they give you, a denominator cannot be 0. That's your first step. Denominator, take your denominator and set it equals to not 0. So x cubed plus 7, x squared plus 6x. This denominator, we don't want that to be 0. And then your goal is to solve for x. It means you factor and you solve. So 3 terms, what do you notice first? GCF. So you get x squared plus 7x plus 6. What do you notice now? Can you factor more? X plus 6, x plus 1. Don't forget about your GCF. And don't forget about your not equal to 0. So we factored here. This is factoring. And now we are going to do solving. To solve, we just solve like 0. X cannot be 0. X plus 6 cannot be 0. X plus 1 cannot be 0. This is already solved. We stop. This gives us x cannot be -6. And this gives us x cannot be -1. We are solving -6, -6, -1, -1. And then this says write in interval notation. Write the domain in interval notation, okay? So interval notation means you want to see which intervals we have in our domain. So it cannot have -6, it cannot have -1, and it cannot have 0. So your interval, the first interval is here, -∞ to -6. We cannot use the 6, so it's parentheses. Second interval is this one. It runs from -6 to -1. The third interval is here. It runs from -1 to 0. And lastly, this is the last interval. It runs from 0 to infinity. So basically, you write three numbers and those numbers twice, once for each interval. So 6, 6, -1, -1, 0, 0. So you write them twice together, once for each interval. And then for multiply, you do 3 steps. What are the 3 steps of multiplication? Factor, cancel, rewrite. So I'm not going to do any example. I'm just going to show you something like this. 2 terms means either GCF or perfect square. So this is GCF and this is perfect square. And then 3 terms means you factor directly. Once you factor, you see anything from the numerator and anything from the denominator, can you cancel them? If you can, just get rid of them. And then lastly, whatever remains at the top divided by whatever remains at the bottom. You rewrite. For division, is the exact same thing. The only difference is you do one more step. First, you keep the first fraction, change your division into multiplication, and you flip your second fraction. Once you flip, and then you do factoring, cancel, and okay. So if you know how to multiply, you know how to divide. The only difference is you do this step and then you do multiplication. I actually did 2 examples with my morning class. So whatever you missed here, you can go watch the morning review. Good luck, everyone.
Oh, I can wait.
I didn't